All right, so let's see what's going on in this chemical reaction. So on the reactant side, we have an iron oxide. This is ferric oxide right over here, reacting with sulfuric acid, and it's producing, let's see, this is ferric sulfate and water. And we want to balance this chemical equation, and I encourage you to pause this video and try to balance this. So I'm assuming you've had a go at it, and you might have been able to successfully balance it. And if you weren't able to successfully balance it, one theory of why you weren't able to is because this sulfate group made things really confusing. You have 4 oxygens, 3 oxygens here. You have 7 on this side. Then you have 4 oxygens in the sulfate group here, but you have 3 sulfate groups. So this is 12 oxygens here, and then you have another oxygen here. This seems really confusing, especially with all the sulfate group business. And the key here is to appreciate that the sulfate group is kind of staying together. You can kind of treat it. You can, instead of just saying, hey, let's try to balance all of the oxygens, you can say, let's balance the oxygens that are outside of the sulfate group separately, and let's balance the sulfate groups separately. And to help our brains grapple with that, I'm going to rewrite this chemical equation with a substitution. I'm going to say, let's say that X is equal to a sulfate group. So let me rewrite all of this business. So I have, it's nice to have, I guess this is close to a rust color, which seems appropriate. So let's say I have some ferric oxide. I'm just rewriting what I have above right over here. Ferric oxide plus some sulfuric acid. But instead of writing H2 and then writing the sulfate group, I'm going to write H2 and then X. H2 and then X is going to yield ferric sulfate. Ferric sulfate. It has 3 sulfate groups. So X is a sulfate group. And it's going to have 3 of them. Ferric sulfate plus molecular water. And so now, even though X represents an entire group, let's treat it like an element. And just let's make sure we have the same number of X's or the same number of sulfate groups on both sides. So let's balance this chemical equation. So let's start with the iron. So over here I have 2 irons. And over here on the right-hand side, I have 2 irons, so it doesn't feel like I have to tweak the irons at all. Now let's move on to the oxygens. I have 3 oxygens here on the left-hand side. On the right-hand side, I only have 1 oxygen, but I can change that by saying let's have 3 water molecules. So then this is going to be 3 right over here. And now let's focus on the hydrogens. Focus on the hydrogens. I have 2 hydrogens here. And I have 6 hydrogens right over here. So if I have 6 hydrogens right over there, how do I get 6 hydrogens here? Well, I'll have 3 molecules of sulfuric acid. Each of them have 2 hydrogen atoms. So now I have 6 hydrogens. So my hydrogens, my irons, and my oxygens that are not part of the sulfate group are all balanced. Now let's see if we can balance the sulfate groups. So on the left-hand side, I have 3 sulfate groups. Let me do that in that magenta color. So I have 3 sulfate groups. And on the right-hand side, I also have 3 sulfate groups. So I'm all balanced. And if we want to unsubstitute, we just go back up here. Okay, we didn't change the coefficient on this molecule, on the ferric oxide. We did change the coefficient on the sulfuric acid. We say we have, for every molecule of ferric oxide, we have 3 molecules of sulfuric acid. We didn't change this. They're going to yield for every 1 molecule of ferric oxide and 3 molecules of sulfuric acid. It's going to yield, the products are going to be 1 molecule of ferric sulfate and 3 molecules of water. And we are done.